Welcome to our Get More Insights on degree requirements for studies in mathematical sciences and actuarial math. So first we have the general WPI distribution requirements. You have 15 units in total required to graduate. 5 units are school-wide. 2 units of arts and humanities, 1 unit for your IQP, 2/3 units for social science, and 4/3 unit other. Then you have 10 units defined by your individual programs, by your major. For our actuarial major, we have the following distribution requirements. 7 units of math that must include 3831 and 3832, that's the real analysis 1 and 2 sequence. 3257 or 3457, those are 2 different numerical methods courses. 3631 or 4632, these are mathematical statistics courses. 2 transition courses and your MQP. Then you must have at least 3 of these 4 courses, which are specially designed actuarial mathematics courses that align with the syllabi of the actuarial exams, the society exams. For related non-math, we have to have 8/3 units, and those must include 2/3 unit computer science, 2/3 unit basic science, and 4/3 unit business. We then have 1/3 unit free elective and the actuarial seminar. So this is your actuarial major in a nutshell. For the mathematical sciences major, we have the following distribution requirements. We have 7 units of math. These must include 3831, 3832, that's the real analysis sequence, 3257 or 3457, 1 of 2 numerical methods courses, and then 3823 or 3825, 1 of 2 algebra courses, the first being group theory, the second being rings and fields. Then we have 3 transition courses in the MQP. You also need at least 7/3 units of 3000 or higher level math, and then 2 units of related but non-math courses, including 2/3 unit computer science, 2/3 unit basic science, and 2/3 unit science, engineering, computer science, or business, and then 1 free elective, 1 unit of free elective, so 3 free elective courses. That's our math sciences major in a nutshell. To talk more specifically about the courses, we have our introductory math courses. At this stage, you've already taken some of these, and so we have Calc 1, 2, 3, and 4, as well as the Intro to Analysis 3 and Intro to Analysis 4. These are the more theoretical versions of Calc 3 and 4 offered in A and B term. And then we have the courses beyond calculus, Bridge to Higher Math, Intro to Differential Equations, Linear Algebra 1, or 2073, which is Advanced Linear Algebra 1. That's available in C term, Applied Statistics 1, and Discrete Math. So these are all introductory level math courses. One key one that we want to focus on is Math 1971, Bridge to Higher Math. This is a course that runs in D term, and it really is incredibly useful to take as a math major or an actuarial math major. This introduces you to mathematical thinking, logic, and reasoning. And it's important to recognize that as you move into a math major, you move away in many courses from just solving problems to proving theorems. And math is really about making a conjecture and then trying to prove it. And this is a course that really is a boot camp in that. It trains you how to explain, justify, defend, disprove conjectures, and verify mathematical ideas, both verbally and formally in writing. You can learn how to formally write a mathematical proof very well in this course. And so this is not required, but it is highly recommended for mathematical sciences or actuarial math majors. This course will pay serious dividends for many of the 2, 3, and 4,000 level courses you will take later. After the first year, we start to get to a point where we have to feel around in the world of math. And that's what the transition courses are really designed for. So math majors must take 3 of these, actuarial majors must take 2, and there are 5 transition courses to choose from, all listed here. We see probability is offered in both A and D term, math modeling with differential equations in B term, matrices and linear algebra 2 in C term, graph theory in D term, and combinatorics in D term. These two are every other year courses. They alternate. And it's really helpful to take these courses because they help you transition into the math major by focusing on proof and rigor. And so you want to be choosing some of these to align with your interests and also what you think you might want to specialize in. And that's when we get into the entire major, which can be reflected pretty well with these program charts that we have. So here we have a program chart for actuarial math, and here we have a program chart for mathematical sciences. These are in the undergraduate catalog. These are very handy to look at, and they give a nice visual breakdown of how the major works. So here, if we look at the actuarial math first, we see we have our introductory courses, transition courses, core courses, actuarial courses. These form our foundation courses. And then you see in this next level, you can choose courses from these different blocks. And so we're going to choose from actuarial math, analysis, algebra, so on and so forth. This is a very nice way to visually organize the major. For the mathematical sciences major, we have the same kind of thing. And here, you have to choose your specialty. Realize that when you're in actuarial math, you really have chosen your specialty as actuarial. Here, you have to decide what kind of math interests you. And it's important to recognize that our math major is far richer than most math majors at schools of comparable size. And that's really because we are such a STEM-focused school. Our math department has to have a very diverse catalog of courses. But the result of that is that you don't just take everything. You can't. There's too much to take. So you have to develop an idea as you work through your studies of what type of math you're interested in. Are you more of an analysis person? Or do you steer towards probability and statistics? Or computational math or discrete math? You have to get a sense of what you want to study, what you like, and that will guide you to choices for those 2,000, 3,000, 4,000 level courses. Notice that we mentioned both majors require computer science courses. And so you have to take some kind of CS course. It's a good idea to take programming courses. No matter what type of math you are interested in, no matter what you want to do with math later, whether it's graduate school or go into industry, you have to be familiar, typically, with some type of computer programming. In real life, math is implemented through computers. And knowing how to program is absolutely essential, both in grad study and in industry. That's why we have these requirements. It's important also to plan ahead. So you want to make sure that you have your practicum lined up. You want to make sure that you're satisfying all of your degree requirements across your 4 years of study. You also want to make sure to plan for your IQP and your MQP. You want to start early. For your IQP, are you going to be abroad? Are you going to be on campus? If you want to be abroad, you have to apply to these different project centers. That takes time, and that takes work. This also has implications for your course selections, because if you are away for your IQP or your MQP, you can't take courses on campus. Also, in either major, note that you have to take that real analysis sequence. You want to take them back to back. It can be either AB or CD terms, but you don't want to wait until your senior year, and you don't want to take them too early. You want to take those courses when you're ready to go into a serious proof-based analysis course. So it helps to have things like Bridge to Higher Math under your belt, some transition courses, so you've had some experience with proof. Then you want to make sure to plan for your MQP in your senior year. And part of planning for your MQP is working with professors. When you take a course in an area that you like, you want to get to know the professor. Getting to know your professors, working with your professors who are in the areas that you're interested in, can help guide you to an MQP advisor in an MQP topic. When you're taking a class and you really like the math, go to office hours. Set up a meeting with the professor if you think that you may be a good MQP fit. Don't wait. You want to think of your studies as a path that guides you to your MQP project. And so you want to be actively seeking both a topic and an advisor as you study here. If you find yourself interested in a topic and you're not taking a course with a professor in the area, you could email them and ask them to meet for a discussion about a possibility of an MQP. Double majoring. If you're double majoring, this requires a lot of careful planning, in particular for your MQP, because you either have to do 2 separate MQPs or 1 4/3 unit MQP that's advised by faculty in each of the departments. BSMS. If you think you might do a BSMS degree, this also requires careful planning. The BSMS degree, where you pair with one of the mathematical sciences master's degrees like financial math, industrial math, applied statistics, or applied math, all of these have some courses that are strict prerequisites for other graduate courses. Those are typically offered in fall semester. It will be very important to pick up some of those in either your junior or senior year to be able to successfully complete the master's degree in 5 years. And so that is a very important thing to plan for very early on, talking to your academic advisor. Some of you may be interested in teaching. This is a good option for some career flexibility as well, and you can teach with either a math or an actuarial major. To do this, you need to use the social science requirement to take Psychology 2401 and 2406. Then you take ID 3100, Teaching Methods, in D term of your sophomore year. And in your junior year, your IQP is teaching, student teaching. Then you take and pass the Massachusetts MTEL exam. And once you begin teaching, you then have 5 years to take some graduate courses to get a master's degree. Yet another advertisement for the BSMS program. We also have tracking sheets at this website here. These are extremely handy. We highly recommend that you use these because they are specifically designed to help you plan out your major. So this gives an overview of the degree requirements and general planning for your studies in both mathematical sciences and actuarial math. If you have any further questions, don't hesitate to contact us in the mathematical sciences department.